in this graph that we have right here, what is set 1? No. Set 1 is types of dog. That's the set. Now, what are the elements of the set? If only there was some sort of way to record me saying...
I need to bring this home or not.
Bring it home.
Dogs.
What are the elements? The elements are hound, chihuahua, and so on. Okay? What is set 2? And what are the elements? No. 60, 11, 30, and so on. No, because there is no data for 40. There is no data for 50. There is no data for 70. There is no data for 90. There's only data for those 6 numbers. Is everybody good? Okay. Yes. When the bell rings. Now, is everybody comfortable with sets and elements? Yes? We're all good? Okay. Now, is this a relation? You've got the definition written right on your page. Is this a relation? Yes, of course it is, because I am comparing 2 sets of data, yes? I have one set of data, a bunch of different types of dogs, and I am comparing those dogs to their average heights. Everybody cool? Easy peasy lemon squeezy. It's a relation, yes? Okay, now. Turn the page over, and we see the word function. Highlight that because it's a new word. A function is a special kind of relation whereby elements in one set relate to unique elements in the second set. Try to leave some blank space down here because I'm going to talk a little bit more. All right, so to recap, a relation is any time you compare 2 pieces of data. A function is a special kind of relation. Therefore, all functions are relations, but not all relations are functions. Is everybody cool? All right. So now go back to here. Set 1, I did that in pink. Set 1 was hound, chihuahua, corgi, lab, shepherd, and malamute. Agreed? Okay. Set 2, what was the hound's height? 60. What was the chihuahua's height? 11. I'm sad Chihuahua is even on here because they don't deserve to be called a dog. Corgi, lab, shepherd, malamute, 80. Is this a function or is it a relation? We already know it's a relation. Is it a function? Some people are shaking their heads. Some people are doing nothing. Why is it not a function? Not Corgi and Lab. Look again. Najim? Doesn't have to be a pattern. No, there doesn't. Lab and Shepherd are the same. They have... Lab relates to two different heights. The two different heights relate to two different dogs. Here's what I mean. How tall is a Corgi? How tall is a Lab? 45. No, average dog heights, Selena. How tall is a Malamute? 80. Everybody cool? Easy peasy, right? I am thinking of a dog that is 60 centimeters tall. What dog am I thinking of? A hound. I am now thinking of an organism that is 11 centimeters tall. I said organism. Get your minds out of the gutter. Chihuahua. Now I am thinking of a dog that is 45 centimeters tall. What dog am I thinking of, Brittany? Brittany. What dog am I thinking of? Wrong. Gervine, what dog am I thinking of? Wrong. Varsha, what dog am I thinking of? Wrong. Preston, what dog am I thinking of? Wrong. So, why am I able to say wrong to everybody? Because you cannot tell which dog I am thinking of because there is not a unique comparison. Is everybody with me? Why are you guys locked into average? That's got nothing to do with it. If I took 500 hounds and measured their height and added it up and divided by 500, the answer would be 60. It's got nothing to do with this. Positive. The 2000th time I've taught this, and it's the first time anybody's gotten hung up on, is it the average height? Turn the page over. Now, all of you in about, well, not all, as I have gotten older, less and less kids have seen what I'm about to draw. But when I first started teaching, every kid had seen this. In about grade 4 or 5 or 6, somewhere in your math textbook, you saw something that looked like this. No, it's not a Chihuahua. No. Would you just wait a second? And you dropped in a number, 3, and then you added 3 to get what? 6, and then you subtracted 4 to get what? 2, and then you multiply by 7 to get what? 14, and it spit out a 14. And they called this a function machine. No. Many of you have seen something like this, and I know this because Preston just said, input, output, input, output! Because that is what this is. I input a 3, I then did a bunch of math, and I output a 14. Okay? Come back to here. I am going to input hound. What is the output? 60. I input Chihuahua. What is the output? I input Corgi. What is the output? 30. Average. Everybody good? Okay. My inputs, no matter what number I put in here, I will get a unique number over here, won't I? Because no matter what I put in here, will any other number than 3 get me an output of 14? Will any number other than 3 get me an output of positive 14? No. So this would create a function. Okay? Yes. Now, let's see if you can apply it. In this question, each month of the year relates to a number of days. Is it a function or not? First, what is set 1? What is the first set of data? The months. What is the second set of data? The days. What are the elements of the first set? January, February, March, April, and that's enough to prove my point. What are the only options for elements for days? 28, 29, 30, 31. Right? Pardon me? That's what the 29's there for, Jenna.
So the days are also elements.
The days are elements because they are the pieces of data in the set. All right? Now, January is my input. What's my output? Input, January, output, 30. Is that a function? Yes, because I input January, I got out 30. Unique. I input February. What do I get? 28. Or 29. Is it a function? Oh, sorry, 31 for January. Thank you. 31. 30 days, has September, April, June, and November. Yeah. Input February, get 2 outputs. Is it a function? No. This is a relation. Because February gives 2. I know it just turned blue. February gives me 2 different outputs. Now, if we continue on, we are going to have problems further, aren't we? Because March has how many days? 30. We're still okay. 31. And April has how many? 30. So, 31 repeats. If February is not there, are we okay? We are, because January gave me 31. March gave me 31. That's okay. That input gave me an output. Only one output. But the input of February messes us up. Because February can have 28 or 29 days. Is everybody cool?
But for the function, like without February, that wouldn't be a function though. Right?
It's still a function.
But there's 2.
But each input only gives me one output. Okay, Kate, stop. This is a function because no matter what I put in here, I get a unique number, yes? Okay. No matter what I enter without February there, how many outputs does January have? 1. How many outputs does March have? 1. How many outputs does April have? 1. So it's a function. February ruins it because February has 2 possible outcomes. Okay? Let's do another one. What is the set 1 here? The names. What is set 2? The kid. Right? Everybody agree? If I input a name, oh, those are supposed to be green. If I input a name, Adara, how many kids have that name? 1. That kid right there. Everybody agree? If I go by first names in this class, is this a function? Yes, why? No repeated names. If I go by last name in this class, Natasha and Vonnie are both thins, yes? So if I write last name, it could be Natasha or it could be Vonnie. So if I use last name only, is it a relation or a function? Relation. If I use first name only, what is it? Function. What if I use last and first? Function, unless you're in grade 11 in this school, because there's 2 Jazreet Dillons who even have the same middle name. Yeah, and they were both in my homeroom last year and both in my classes. It was a super pain in the ass. Fortunately, they both know their student number, and I could always track them down. Is everybody good with this now? Go for Myers. Hey. No problem. I left to pee, I came back, big cloud of vapor coming out of his mouth. In my classroom. I know, I couldn't believe it either. It was awesome. Sweet! Thanks, Mr. Steele. Bye-bye. Woo! 3-day suspension for lameness. What?
Other things that the dogs, I thought you said it was a function because there was 2 that were the same. So then for the dogs, it's not a function?
Yeah, the dog's not a function.
Okay, the dog.
The dog is a relation. Are we all good? Are we all good? Okay. So now we got some more vocab. Dependent variable, independent variable. In English, what does dependent mean? You depend on something else. For example, if your parents suddenly said, I am not going to pay for your housing, your clothes, and your food anymore, would you be in trouble? Very much so. So you people are dependent upon your parents. Right? Okay. Are your parents dependent upon you? Not even a little bit right now. Possibly in the future, possibly, but not necessarily. No, again. Listen, if you people suddenly decided that you were going to do nothing around the house, could your parents continue on? Yes. Right? If your parents decided they were going to do nothing for you, could you continue on? Not in the method to which you have become accustomed. Does everybody understand? If your parents change their ways of dealing with you, you're in big trouble. If you change your ways of dealing with your parents, does it really hurt them? No. Is everybody cool? Okay. So the dependent variable is anything that is subject. I wrote subject to all on Word. Subject to another variable. Okay? Oh, I should probably remind you, what's a variable? Because when I say what's a variable, every one of you says X. What is a variable? Good. Unknown value. What else could it be? It's not. No. It's an unknown variable. Or what does the word variable mean? If my mood is variable, what does it mean? Changes. A variable is anything that can change. Anything. Okay? So the dependent variable is subject to another variable. Right? Your parents could change their mood, couldn't they? And if they do, you're in trouble. If you change your mood, does it really affect your parents? No. Everybody cool? So the independent variable is anything that stands alone. Okay, no, it's not a constant. Because a constant can't be variable. A constant is always there. Is everybody cool? All right, now, 2 more words. Domain. Domain is the set of values that comprise the IV, independent variable. So what then is the range? Set of values that comprise the DV. Okay? The domain is not the independent variable. It is the values within the independent variable. Is everybody good? Okay? Don't do that. What?
What are the values? Like, what is a value? Like, is it like
7.
okay? So like
That's a value. Okay? Okay? All right. I probably should have said elements. Is everybody cool? All right. Now your next page has a bunch of this stuff. Now let's talk. We're running short on time. I want to get number 3 done. There's 2 variables in this question. 2 things that can change. What are they?
Just a reminder, students, at lunch there'll be pizza for sale in the rotunda. That pizza will be for sale in the rotunda.
What are the 2 things that can change here? Hours worked and the pay. Which one is independent? Hours are independent. Why? Because your pay depends upon how many hours you work. So what is the domain? Hours. What are the possible amount of hours I can work in a week? Can I work 0 hours? Yes. 0. What's the maximum amount of hours I can work in a week? Many of you probably won't know this. Before I start getting paid overtime, what is it? 40. My domain is 0 to 40. Everybody cool? All right. Now, can I work fractions of those hours? Yes, of course I can. But for our arguments, we are going to say she only works whole hours. Everybody cool? Okay. What is... Damn! 9-0 up to what? 40 times 950, right? Because that's how much she could work. 40 times 9 is 360, 380. Is everybody cool? So, oh, crap. This was our domain and range. These should have been down here. That's the domain. That's the range. Function or not? Yes. Every hour she works, she gets paid more. She will never be paid the same amount if she changes her hours. And that's where we're stopping. See you tomorrow.